Okay, units, in this video we are going to solve an integral equation. Now, the Laplace transform has the capability to solve differential equations, but also solves integral equations, or can also solve integral differential equations. So that is why the Laplace transform is more flexible, has more capability, because it not only solves differential equations, also integral equations. Now, you can see this is the problem. Now, f of t is equal to 3t squared minus exponential minus t, minus the integral from 0 to t of f of tau, exponential of t minus tau, differential of tau. Now, this f of tau and this f of t, they are the same. Now, the problem is to clear the f of t from here. Now, this is a very difficult problem because you cannot take outside f of t outside of the integral in order to factorize the f of t. So this is actually a very difficult problem, but with the Laplace transform it becomes very easy problem. Okay, now let's solve it. The first thing to realize is that this part, this is actually the definition of the convolution theorem. Let me remind you the definition. The definition of the convolution is f of t convolution with g of t is equal to 0 integral from 0 to t f of tau g of t minus tau, differential of tau. And let me remind you the Laplace transform of the convolution, it is actually just f of s times g of s. So as you can see here, this integral is a convolution of what? Of f of t with convolution with exponential of t. Alright, g of t minus tau, exponential of t minus tau. So that means that the g of t is just the exponential, and here is the f of t. So let's rewrite this from this equation like this: f of t equal to 3t squared minus exponential minus t minus f of t convolution with exponential of t. Now, what is the advantage to know that is that if you apply the Laplace transform, the Laplace transform of f of t is equal to 3 the Laplace transform of t squared. We apply the Laplace transform of each one of the terms minus the Laplace transform of the exponential of minus t minus the Laplace transform of f of t convolution with exponential of t. Okay, so the Laplace transform of f of t, because we don't know what is f of t, we are going to leave it like that. F of s equal to the Laplace transform of this 3 is going to be 2 over s to the power of 3, alright, minus the Laplace transform of the exponential 1 over s plus 1, okay, and then the Laplace transform of the convolution, as we saw in the previous video, is just the multiplication. So this is going to be minus f of s times the Laplace transform of this 1 over s plus 1. Now, on the s domain, we can factorize the f of s. Now, it is possible. In the t domain, you cannot factorize the f of t. Now, on the s domain, you can do it. Now, we are going to pass this to the other side. So, f of s plus this minus becomes positive. F of s times 1 over s plus 1. And this is equal to 6 over s to the power of 3 minus 1 over s plus 1. Let's do the common denominator here. S to the power of 3, s plus 1 here is going to be this divided by 6s plus 6, and then minus s to the power of 3. Okay. Okay. Let's continue. Okay. Now let's factorize from this side. F of s times 1 plus 1 over s plus 1 equal to s to the, 6s plus 6 minus s to the power of 3 over s to the power of 3 s plus 1. Now let's do the common denominator here. So it's going to be f of s times what? S plus 1. Here is going to be s plus 1, and then plus 1 plus 2. Alright? Equal to 6s plus 6 minus s to the power of 3 divided by s to the power of 3, s plus 1. Now you can see here this and this cancels, and this goes as a division, so f of s, so clearing the f of s is going to be 6s plus 6 minus s to the power of 3 over s to the power of 3 times s plus 2. Alright? Okay, to find the value of f of t, what we have to do is partial fractions on here, and then apply the Laplace inverse. Okay, so the partial fractions is, they are a over s to the power of 3 plus b over s squared plus c over s plus d over s plus 2. Okay, now, because we have repeated roots here, we can only use the Heaviside method on A and on D. Okay, let's find the values of A and D. So A is equal to 6s plus 6 minus s to the power of 3 divided by s plus 2 when s is equal to 0. So when s is equal to 0, the value of A happens to be 6 divided by 2, 3. Okay, we got the value of A. Now the value of D is going to be 6s plus 6 minus s to the power of 3 divided by s to the power of 3, and this is with s equal to minus 2. Okay, so minus 2, minus 12 plus 6 minus 6, and then minus 2 to the power of 3 is going to be minus 8 plus 8 here, divided here by 8 minus 8. Okay, just let me check. Minus 12 plus 6 minus 6, and then plus 8. Okay, so it's going to be 2 divided by minus 8 is going to be minus 1/4. Okay, so that is for the values of A and D, but what about B and C? Okay, we don't have other choice but making the common denominator. 6s plus 6 minus s to the power of 3 is equal to the common denominator here, this divided by this, A, but the value of A we already know, 3s plus 2 plus B, this by bs, s plus 2, this divided by this, c, s squared, s plus 2, and then this divided by this, d, but the value of d we already know, 1/4 of s to the power of t. So what we have to do is to choose some values to get b and c. Okay, so let's do it. Okay, I'm going to choose an easy number. Easy number is going to be, we cannot repeat the values of s equal to 0 and s equal to minus 2, so I'm going to choose s equal to 1. So if s is equal to 1, so this is 12 minus 1, 11. Equal to s equal to 1, 3, 9 plus b times 3, and then plus c times 3 here, minus 1/4. Okay, so 11 minus 9 is going to be 2, plus 1/4 is going to be 2 plus 1/4. This 2 is going to be 8/4, so that is going to be 9/4. Okay, so 3b plus 3c is equal to 9/4. If we divide by 3, so it's going to be b plus c equal to 3/4. Okay, so that is the first equation. Okay, the other equation, let's choose s equal to minus 1. Let's see what happens. Minus 1 here, minus 6 plus 6, 0, and then minus 1 to the power of 3, negative, and then it's going to be equal to 1. 1 is equal to minus 1, 3 here, plus b minus b here minus b here, because minus 1 and 2 is equal to 1 positive, and then plus c here minus 1 positive, okay, minus plus 1 quarter. Okay, so 1 minus 3 or b minus c is equal to b minus c, this to the other side and this to the other side, 3 minus 1, 2, 2 and 1 quarter plus 1 quarter, 8 quarters, 9 over 4. 9 over 4. Okay, now we have this plus this. Okay, we have this equation. I'm going to do this equation 1 and this equation 2. I'm going to make the addition. This plus this, 2b is equal to 3 and 9, 12 over 4, 3. So b is equal to 3 over 2. And then the subtraction, this minus this, so it's going to be 2c is equal to 3 minus 6 quarters. 6 quarters is going to be negative, sorry. Is going to be minus, see, 3 minus 3 over 2. Yeah, minus 3 over 2. No, minus 3 quarters, sorry. Minus 3 quarters. Okay, so we got the values of a, b, c, and d. Okay, so the partial fractions are like this. Okay, so let's write the solution. F of s is equal to the value of a is equal to, what is value of a? 3 over s to the power of 3 plus b. The value of b is 3 over 2. 3 over 2 over s squared plus the value of c minus 3 over 4 over s, and then the value of b minus 1 quarter over s plus 2. So what is the f of t? It's just the Laplace inverse. So this is going to be 3 t squared divided by 2 factorial, okay, plus 3 over 2 t squared, t only t, and then minus 3 quarters, and then minus 1 quarter of the exponential minus 2t. And that's it. Now this is the solution of this is the f of t. Now this is very interesting because this is the f of t such that if you replace it here and you make the addition of this is going to be equal to itself. Okay, engineers, this is one of the typical problems in the homework, so I hope you pay attention on the procedure. Please let me know if I have a mistake here. I may have a mistake like an operation here, but this is in general the procedure. Alright, see you in the next video.